Hello everyone, welcome back. In this video I'm going to talk about something called compiled blocks in Houdini and how we can use this feature to optimize our networks and speed them up. So in this example I have a grid, then I'm gonna run it through some noise. So we have this function that we like to apply to our input geometry, and we saw that in our fracture node we have this guy here. We have this guy here, and it's a duplicate of this node. So this is what deforms the geometry and pushes it. This is the noise function. But we're actually duplicating the node. Okay, and if we needed it in more places, we have to copy it more. And basically, every time we have to make sure that this node exists and up to date. And we don't want to do this duplication. We don't want to repeat the same node over and over. We want to use a feature of the compiled block where we can create a set of nodes, for example these, and say, okay, this guy, this chain of nodes, I want to be able to switch their inputs dynamically and let them give me the result based on my new input. So we put them somewhere like a function and say, okay, this is my null, this is my input, and this is my input output, and here I'm gonna say, okay, with this geometry what I want to do is I want to take this data, pass it through this chain and get the result back. So that's what this technique is going to allow us. And this is, think of it as a function. Like in programming, you create a function to do certain operations, and then you want to swap you want to call it with multiple inputs with multiple variables, and you can call that function an infinite amount of time without having to duplicate the same function over and over every time you need it. And so that's the concept with Houdini. So the first thing we need to do is we actually need to create a compiled block. So I'm going to hit tab, type in compiled block, and I'm going to connect this in here. And the first thing we need is we need to name this. We need to name the input. So I'm going to call this in geo. Okay, and then here we're going to use a node called invoke compiled block. Okay, so this is a compiled block, and then I'm going to say, okay, I'm going to invoke this guy, and I'm going to swap the input, which is it doesn't have anything, just a placeholder now, and then we can call this set of nodes with different inputs using this node. Okay, so the first thing is I'm going to drag and drop the compiled block node. It's the last node. Okay, I'm going to drag and drop it here, and then here the first one maps to this guy. I'm gonna say, okay, I want to pass this information to here, and the way to do this mapping is using the name which we specified here, input name. So that's gonna be, sorry, the input name here, and that's gonna be input geo, and boom, now we're taking this input, evaluating this graph, and it's giving us back this output. And now all I have to do is I'm gonna create a new geo, let's say a sphere. I'm gonna copy this, and now it's working on that sphere. So we don't have to duplicate this, and I can make it as you know, we can let's say we have a divide node on this graph. Obviously when you view it nothing's gonna happen, but now it's working on these guys, and I can change them in one place and it will propagate to all of them. And this is valid for this set of nodes here. We have two states. We either have to use the original geometry as it is, or use a loop for each loop. So let's implement this here. So this is how my network looks like right now, and this node is duplicated. So I'm gonna cut this from the chain, and I'm gonna create a compiled block and just paste this here. I'm gonna call this in geo like we did, And I'm going to delete this node and create an invoke block and paste this guy in geo, and now that's our result. And I'm going to copy the same thing and paste it here. Right now it doesn't have an input, that's why it's giving us an error, and this is the first level, so I'm going to go up and let's make sure we're looking at the right result. Okay, so that's our result, and then I'm going to copy this node and I'm going to do a second loop. So I want to loop over the pieces using this attribute, and the result is going to be center ID 2, and let's change the scatter points to something like that. And as you can see, it's working, and we're only using these guys. So this is very, very efficient and very useful technique to simplify the network quite a bit whenever you have to duplicate a node or something like that. Cool. And the next video we're going to look further into the compiled block, and it's actually something that we can use to multi-thread certain parts of the network, especially the for each loop. We're going to learn how to implement that here to speed this process and make it multi-threaded. Thank you guys for watching, and see you in the next video. Bye bye.